Hey everyone, I hope you guys are doing well and staying safe. In this video, I will be doing my presentation on a paper titled Individual Behavior and Resource Use of Thermally Stressed Brook Trout, Salvelinus fontinalis, Pretend the Conservation Potential of Thermal Refugia. As we all know, a big conservation and environmental concern for many species is climate change. With rising temperatures, there is concern with how cold water species like trout will respond to these increasing temperatures in streams. The focus of this paper is brook trout, which are the only native trout on the East Coast. There have been observational studies on rapid movement of fish to thermal refugia as stream temperatures become physiologically stressful. So this study wanted to see what individual attributes could predict how fish compete for thermal refugia. Overall, this paper just looked at brook trout response to increasing stream temperatures. The study was conducted at the U.S. Geological Survey Leetown Science Center in West Virginia. It was done by scientists part of the Pennsylvania Fish and Wildlife Research Unit, the Department of Ecosystem Service and Management, and the U.S. Geological Survey. The study was held at an indoor stream laboratory at the USGS Science Center where there were four 7.6 gravel-bottom stream channels, each consisting of 3 pools and 2 riffles. A belt feeder was located in the upstream riffle, periodically delivering fish pellets during daylight hours. To ensure that food was a limiting resource for brook trout, the amount of food in each stream was restricted to 1% of fish biomass per day. The trial consisted of 3 8-day temperature tests with ambient stream temperatures being manipulated from 14 degrees to 23 degrees Celsius. The thermal refuge area was in the last pool, where an area of groundwater upwelling was stimulated by introducing 14 degrees Celsius spring water. The study used 1-year-old brook trout from the West Virginia Ridge Creek hatchery. Prior to beginning the actual study, observational data was taken from the fish to see their individual personalities. They were basically looking for any exploratory behavior. After fish behavior was monitored, they then measured the fish for length and evenly distributed the fish among the 4 streams. This equated to 17 fish per stream. The main question the study hoped to answer is why is there a rapid movement of fish to thermal refuge as ambient stream temperatures become stressful? They were also interested to see if there was competition for space and if anything could predict movement. There were 2 main hypotheses. Competition for space inside thermal refuge limits occupancy to only include dominant individuals, and refuge habitats are devoid of necessary resources, and individuals must frequently move among several habitat patches to feed, avoid predators, or conserve energy during high flows. The 2 objectives are to determine whether individual attributes could predict how fish compete for access, and explore how fish size and personality influenced average resource use. Based on this, they also wanted to see if changes in resource use with increasing temperatures existed. So these are the results. Figure 2 shows aggressive behavior, while figure 3 kind of describes resource use. So here, on average, fish with more exploratory personalities initiated more aggressive interactions. Average aggression also increased with size. And 2C indicates that there's not really a correlation between individual personality and change in aggressive behavior with response to temperature. Lastly, 2D shows that there is a decrease in aggressive behavior in response to warmer temperatures. 3A shows that resource use is not influenced by fish personality. However, larger fish are more likely to occupy areas near the feeder, which is shown here. 3C indicates that there is not really a correlation between individual personality and change in resource use, while 3D shows that fish size negatively influences forage patch use with increasing temperatures. Overall, the negative effect of fish size on forage patch use and aggression across temperatures suggests that larger fish may experience higher levels of physiological stress at warmer temperatures. So, in conclusion, fish size can be used to predict variation in behavior and resource use. Larger individuals experience more significant declines in aggression and forage patch occupancy at warmer temperatures, while smaller individuals demonstrated little change in behavior with increased temperature. Even at critical maxima, the smaller individuals had increased occupancy of a thermally stressed forage patch. Fish size is more important in determining the outcomes of competitive interactions than exploratory behavior. Larger, less exploratory fish outcompeted more exploratory individuals for access to preferred habitats. Reduced aggression may explain why refugia are often occupied by a high density of fish, and there was a decline in forage patch occupancy with increasing stream temperature. All fish, however, did spend significant amounts of time outside thermal refuge even when ambient temperatures were above 23 degrees Celsius. So my thoughts are that thermal refugia is important and should be considered for conservation, especially in warming temperatures of streams. With no observed competition for space, thermal refugia can hold a higher capacity for more fish and allow thermally stressed fish to rest. Temporary occupancy of refugia is enough to significantly reduce cellular stress, which allows fish to spend prolonged periods of time in what would otherwise be lethal conditions. Having an area of optimal temperature has proven that it is enough to keep a population going, and we should be looking for places of refugia in warming stream temperatures to see if this could help the conservation of a species. In the study, it was successful for the brook trout. Here's my reference, and thanks. I hope you guys have a good day.